Hey, everybody. Today we're working on from day 1-7. This is problem 7. So we're talking about remainder theorem today. You can read the problem. F of x is this function. It happens to have m's and g's in it. It's divided by x minus 1, remainder's 3. If it's divided by x plus 3, the remainder's negative 1. We need to solve for m and g. So I'm going to shrink that down a little bit. And I'm going to jump straight in. I think this really is like a mechanical problem. That is, if I underline when it is divided by x minus 1, the remainder is 3, that tells me then that if I sub 1 into my function, it has to give me a value of 3. So I can do that. I can set the function equal to 3 when I replace all my x's with a 1. And then I can clean that up a little bit. I'll put in one line of simplifying the right side. If I then went to write that with my m and g isolated, that gets me that down to there, which would be maybe my equation 1, if I wanted to call it that. If I then did the red, so now if I divide that by x plus 3, the remainder is negative 1, then that tells me that f of negative 3, when I sub a negative 3 into the function, it has to give me a value of negative 1. So my function has a value of negative 1 when I replace all my x's with negative 3. So I should be good to calculate my negative 3 cubed. There's a negative 27. My negative 3 squared is a positive 9. My negative of negative 3 gives me a plus 3. And then I have my plus 3 from the function. So if I did the same thing and I just simplified that, then I get my plus 6. And if I went and I wrote that, that could be my version of equation 2. Okay, there's really all like the legwork. Like that is the grade 12 topic. Okay, what I've done in my blue and my red, there is my application of remainder theorem. The rest of that is just me solving the system. So if I went to do the rest of my solution, let's say in gold, that's now my background knowledge. So I'm going to use elimination, and I'm going to take equation 1 and multiply it by 9. When I do that, I'm going to create this gold equation that I would now call equation 3. And now between equation 2 and 3, I can eliminate my g's. So if I just shrink that down, and I'm going to slide it over a little bit, because I'm going to like wrap all the way around into here. So if I took equation 3 and I now subtracted equation 2, that would be a 9 minus negative 7, which is 16. A 9 minus negative 27, that is a 36. And my 9g minus my 9g is 0. Okay, I could go through and maybe I'm dividing that out, but I would love it if we could see that 16 and 36 both have common factors of 4, so I could divide that out and get to an m value of 4/9. Now that I have that, I'm going to sub my m value of 4/9 back into one of my original equations, and I'm going to go all the way back to equation 1 in blue because that's got the easiest values to it. So 1 is going to equal 4/9 plus g. Now I can get rid of my plus 4/9, so I'm going to minus 4/9. That means that my g value is 5/9. Now, maybe, if we're knocking off some rust a little bit with our fractions, you may have taken a bit of a longer approach in here and done your 1 minus 4/9 equals g, and now got your common denominator on the left side, and that's how we get to our 5/9. So when I'm stating the value, I just solved the system. I want to make sure that I'm stating that as a list of values, a set of coordinates. Make sure we put it in alphabetical order. So my G comes first, then my M. And there we go. Okay, I'm hoping that that helps you through problem 7. If we had any hiccups with that, best of luck on the rest of your practice.